Welcome to the fourth lecture of module 3 of the course Game Theory and Economics. So before we start, let me recapitulate what we have done in the previous lecture. What we have done in the previous lecture is that we have discussed various aspects of Cournot model. Cournot model is a model of oligopoly market where there are a few firms who are competing with each other, and we want to find out in this market what is the output level that will be set by each firm, and consequently what will be the total output produced by all the firms put together, and hence what will be the price, equilibrium price in the market. And based on our observations regarding the various aspects of Cournot model, we have found that the Cournot model essentially depicts a situation of prisoner's dilemma, in the sense that the firms are competing with each other, and by competing with each other they are earning a level of profit which is less than what they could have earned had they come together and taken a joint decision as to what output they will produce. That we have seen. Today we are going to conclude that this part of discussion of Cournot model by talking about a general model of this sort of behavior by different firms. So let me start with this discussion. This is the question: a group of n firms uses a common resource to produce output. As more of the resource is used, any given firm can produce less output. Denote by xi the amount of resource used by firm I. I goes from 1 to n. Assume specifically that firm I's output is xi multiplied by 1 minus x1 plus x2 xn. If x1 plus x2 plus xn is less than equal to 1 and 0 otherwise. Each firm I chooses xi to maximize its output. Formulate this situation as a strategic game, compare this with the Cournot model, and find an action profile at which firms' output levels are at a higher level. So, what we have essentially is that xi is the resource used by firm I, and this resource can at most be 1. So, xi can vary between 0 and 1. This is a natural resource, which means that the total amount of resource available in the entire economy is denoted by 1. What we further know is that if ith firm uses this resource xi, it is able to produce some output, and this output, let us call it qi, is given by xi multiplied by summation xi. So let us call xj. J goes from 1 to n. If this is the summation is less than 1 or equal to 1 and 0 otherwise. So each firm, for example ith firm, wants to maximize this qi, which is the output of that firm. What we need to do is that we have to model this situation as a strategic game, find and we have to compare this with the model of Cournot model that we have seen before, and find its Nash equilibrium. So here, if I have to see this as a strategic game, then I have to specify these 3 components. Here the players are the firms, n in number, actions are the resource used, given by xi. Xi is always less than or equal to 1 and greater than or equal to 0. And finally, payoff or preferences represented by the output level which they want to maximize, which is given by Qi So, this is the setting, this is the game theoretic representation of this situation. So, if I have to compare this with the Cournot model that we have seen before, what are the parallels? Remember, in the Cournot model, the firms were maximizing their profit. So, that pi I, the profit of each firm, is equivalent to Qi here, the output that each firm is producing. So, maxim Pi was the payoff function which they were maximizing, and it was given by xi multiplied by alpha minus c minus x1 minus x2. So, this is the profit function of firm I. However, I used Qi I did not use xi, but nevertheless I can assume that Qi is equal to xi without loss of generality. Now, if I compare this with the setting that I have right now, then what are the parallels that we have? The parallel is that alpha is equal to 1, because the first constant we have in this setting is 1, whereas the constant term in that setting was the first constant was alpha. Secondly, the cost of each firm in the Cournot model was C, per unit cost. Here I see that there is no such component here. So, which means that C in the new setting is essentially equal to 0, comparing this with the Cournot model. So, these are the two parallels that we have between the Cournot model and our present model. Now, if I have to find out what is the Nash equilibrium, so we can proceed as we had done before in the previous lecture, that firstly we show or that in the Nash equilibrium the output levels of each firm will be equal. That is not a very big deal, we can just follow the previous technique. The question is, if they are equal, suppose they are equal, that is xi star is equal to x2 x1 star is equal to x2 star, etc., etc., xn star. Suppose this is equal to x star. So, suppose this is the Nash equilibrium output level, and which we can show very easily that they are equal of each firm. Then what is the level? That is an important question. Now, that we can find out by again looking at the first order conditions, because like before as in the Cournot model, the way to find out Nash equilibrium is that we are going to find out the best response function of each firm, and from the best response functions of the firms we can find out the Nash equilibrium by solving them simultaneously. So, for firm I, this is what he maximizes with respect to xi. Now, so first order condition is that this qi, this is qi, this should be equal to 0, which means that 1 minus this entire thing x1 plus x2 dot 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 xn minus xi, this is equal to 0. Now, there is a xi term in this bracket also, in this parenthesis, which means that 1 minus 2 xi minus summation xj, I is not equal to j, it goes to n, is equal to 0, which means that xi half of 1 minus this. Now, what we know is that in equilibrium for all I, and so it means that x star, all this n minus 1 x stars will have to be added up, which means that there are n minus 1 x star, and if I take this to the left hand side, 1 plus n minus 1 divided by 2 . So, this is the Nash equilibrium output level of, not output level, resource used by each firm in the Nash equilibrium. It is given by 1 divided by n plus 1. Now, output level is a little different concept. So, in Nash equilibrium, what is the equilibrium output level? It is given by, as before we have seen, a q star, suppose, forgetting about the subscript, it is given by x star minus all these terms here. So, which means n terms are there multiplied by x star, and so this is 1 divided by n plus 1 and so it is 1 divided by n plus 1, 1 divided by n plus 1. So, this is the output level in the Nash equilibrium which the firms will be producing, each firm will be producing. This is the Nash equilibrium. Now, there is a last part to the question which says that find an action profile x1, x2, xn at which each firm's output is higher than it is at the Nash equilibrium. So, basically what is being asked is that is this a situation of a prisoner's dilemma, in the sense that in the Nash equilibrium we are having an output level which is given by 1 divided by n plus 1 whole square. But is it possible that the firms can produce some other output levels at which that level is higher than this level? Can it be possible? So, is it's in the terms of prisoner's dilemma, is it possible that the prisoners do not confess and each of them will be having higher payoff? Is that a probable situation? Can we find such an action profile? We can take the following. Here what we have here is x star, that is the resource used by each firm, given by 1 divided by 1 plus n plus 1. Now, suppose x, let us call it x bar, is equal to not 1 divided by n plus 1, but 1 divided by 2n. Now, is this greater than x star or less than x star? I claim that x bar is less than x star. Why? If this is true, then this must be true, which means that 2n is greater than n plus 1, which means n is greater than 1, and which is true. Number of firms in this model, it has to be greater than 1, because if it is equal to 1, the model loses the very its very core of it, that there are firms which are taking decision interdependently. So, the number of firms must be greater than 1, otherwise it does not make any sense. Now, if the number of firms is greater than 1, then we know that if I have each firm's resource use given by 1 divided by 2n, that resources is less than the Nash equilibrium resource use. Now, if each firm produces 1 divided by 2n, then what is the output level? What is Qi, for example? It is given by Xi, that is 1 divided by 2n, multiplied by 1 minus, there are n such firms. This, each firm is producing 1 divided by 2n, there are n such firms. So, the total output is n divided by 2n. Which is equal to 1 divided by 4n. So, the output level in this new set of resource use, that is 1 divided by 2n, is 1 divided by 4n. Question is 1 divided by 4n greater than the output level that they were achieving before, which is 1 divided by n plus 1 whole square. Is this true? Let us see. If this is true, then it must happen that 4n is less than n plus 1 whole square. So, this is 0. and which again is true because n is greater than 1. The number of firms can at least it has to be 2, it can be more than 2. In those cases n minus 2 whole square has to be greater than 0. So, we have indeed found a set of resource uses and a set of output levels, consequent set of output levels, which are those output levels which are higher than the equilibrium, Nash equilibrium output levels, which means that this setting that the firms are deciding on their output levels by in a competitive environment, that gives their output levels a lower value compared to an alternative output set of output levels, which means this indeed is a case of prisoner's dilemma, and it basically generalizes the Cournot equilibrium case. People tend to produce more than the level at which their output levels or their profit level could have been higher, and as a result there is a question, there is an issue of overgrazing. There is a common resource here and people tend to overuse that common resource, and by doing so they produce less benefit for themselves. So, that is the general conclusion. So, this is more or less about the Cournot model. Now, one basic fact about Cournot model was that we were trying to model a market where firms are competing with each other by setting different output levels, and these output levels are decided upon strategically, in the sense that I will set that output level which maximizes my profit, whereas I know that the output level set by other firms might affect my profit. Now, so the entire thing is happening through the setting of output levels, but this is not the only kind of way to formulate a market. When Cournot wrote his thesis on how to formulate a market in the early 19th century, later on another Frenchman called Bertrand reviewed Cournot's work, and he came up with an alternative way to model how markets behave, how we can understand markets. So, the next topic that we are going to cover is regarding Bertrand's model. So, this Bertrand model is essentially like the Cournot model, a model of market, oligopoly market, but there are differences in the sense that here it is not the quantity which will be decided strategically by each firm. The output levels of each firm is not the decision variable, rather it is the price. The firms decide their individual prices strategically and try to maximize their profit as they were doing before. So, that is the thing, and so the basic questions that we were trying to answer in the Cournot model remain the same. For example, we are going to look at how the market demand is going to affect the equilibrium. What is the equilibrium to begin with? If the firms earn any positive profit in the equilibrium, what are the output levels and what are the price levels in equilibrium, and we are going to look at if there are some other parametric changes in this setting, like if the demand rises or falls in the market, how is that going to affect the equilibrium? If there is some technological innovation, for example, if the cost of each firm changes, then how is that going to affect the equilibrium? And if the competition changes, for example, if more firms enter the market, is that going to change the equilibrium? So, these are the basic questions that we were trying to answer before, and they remain the same, but the answers might be different here. So, this is the Bertrand model. So, to begin with, firms are there, they are setting prices. So, different firms set their prices differently, might set their prices differently, and the output that they are producing are of similar quality. So, which means that if I set a price, suppose 5 rupees for my product, and my rival sets a price of rupees 4 for his product, and if we take our goods to the market, same market, the customers are not able to distinguish between my product and his product. There is no qualitative difference between the products, and if that is the case, then there is no reason why any customer will come to me, because my price is higher. So, it means that the producer who is charging a low price is going to capture the market. That is one basic inference that we can draw if the prices are the decision variables. So that is the first thing, and secondly, we can also assume that if the prices set by me and my rival is the same price, then we can safely assume that the market is going to be divided between us. So, that is an assumption. We can play around with this assumption. We shall do it later on in some more extension version of this model, extended version of this model. So, like before, the demand function is a linear function, a simple linear function given by q is equal to alpha minus p. Remember, this was the demand function. While talking about the Cournot model, we just inverted it and used the used p as a function of q. So, this q is now taken as a function of p, the original demand function, not the inverted function, and this is true if p is less than equal to alpha, alpha is greater than 0, is equal to 0 if p is greater than alpha. And like before, we are going to assume a very simple cost function, that is Ci Qi is the output level of firm I, Ci Qi is the cost of production of firm I, which produces the level Qi of output. It is given by small c multiplied by Qi, which means that for 1 unit of output, the cost that firm I has to bear is small c. And like before, we are going to assume alpha is greater than c, greater than 0. Now, from this it is clear that if the price that I set is p, then per unit profit is p minus c, because by selling 1 unit of output I am earning p. For producing that 1 unit of output I am bearing a cost of c, which means that p minus c is my profit per unit. My total profit will be how much? This is the profit per unit. I have to multiply this with the total output I am producing, the aggregate level of output I am producing, how much units I am producing. If I set a price of p, what is the quantity that I am going to sell in the market? This is just given by the demand curve. So, q is equal to alpha minus p. This is the quantity that I am going to sell in the market if the price that I set is p, assuming that there are no other firms in the market. Suppose I am the only firm in the market. In that case, profit for me will be alpha minus p, which is the output, multiplied by profit per unit of output. So, this is the total profit. that I am going to earn if I am the sole producer, and if it is the price that I am setting in the market. So, this is the general formula for profit if there is no rival. Before we look into the various nitty-gritties of this model, one more important assumption that I need to clarify is that in this model, if I announce a price P, it may happen that that price is less than the cost of production, that is, that price is less than C. But nevertheless, if I have announced a price, many customers will come to me knowing that price, and then that demand I have to cater to, irrespective of whether I am making loss or a profit. So, it is now my onus to cater to that demand, and we are going to assume that there is no constraint on the firms to produce that level of output, which means that if I have to, if the market demand is 1000 and I am getting that demand, I can produce that 1000 unit of output. There is no restriction on that. It may happen that by producing that 1000 unit of output I am making losses, but that is immaterial to this setting. If I am getting demand, I have to cater to that. So, this is the setting. Now, if I have to model this setting in terms of game theory, again as in any strategic game, I have to specify three components of this game. One is players. Here the firms are the players. So, in general there are n firms. Two, prices. So, what are the prices in this model? Prices are any non-negative numbers. Sorry, this is not, I should not have written prices. This is actions. Prices are the actions. It can be 0 also, hypothetically. And finally, preferences. So, preferences are represented by profit, and how do I represent that profit? So, suppose firm I am talking about firm I, any representative firm. The profit of firm I is given by price is given by P multiplied by Q minus cost. That is the first principle. But if I charge a price of P, then what is the quantity that I get? This is given by demand function, but there is something else. M is the number of firms which are charging the same price, and this price is the lowest price in the market, minus Q of this, where I is one of the So, let me explain this. So, firm I is charging price P. If firm I is one of the M firms which are charging the lowest price, then the demand in the market is going to be divided between these M firms. And so, each firm will get the total demand in the market divided by M, because the market is being shared equally. So, each firm is going to get dP, dP is the demand function, minus the cost, and your cost of production depends on the quantity that you produce. How much quantity are you producing here? It is given by dP divided by M, the portion of the market you are catering to. So, that is why the total profit is P multiplied by Q minus CQ, which is same as P multiplied by dP divided by M minus C, which is a function of dP divided by M. This is true if I is one of the firms charging the lowest price. If not, then what happens? Pi I is equal to 0 if I is not if I is not one of the firms charging the lowest price, then I is not getting any demand in the market. In that case, it does not produce any output. If it does not produce any output, its cost is 0, the revenue is also 0, because it is not catering to any demand. So, this is the story. Notice if I is the only firm which is charging the lowest price, in that case M is just equal to 1, which means that the profit function is just P multiplied by dP minus C of dP, M is equal to 1. So, this is the general setting. These are the preferences, and the preferences are represented by the profit function. Now, what we are going to do now is that we are going to find out the Nash equilibrium of this model, and while doing so, we are going to simplify this model a little bit. We are going to assume that there are only 2 firms. So, N is equal to 2, and like before, the demand function is given by D is equal to alpha minus P, and the cost function is given by CQ is cost of production is just unit cost small c multiplied by the level of output. Now, if that is the case, then what is the profit that each firm is earning? I can succinctly write this as follows. If firm I is the I which is charging the lowest price, then we have just seen that the profit that it is going to earn is given by this, where Pi is the price charged by firm I if Pi is strictly less than Pj. Remember, there are only 2 firms, 1 and 2. If I is equal to 1, j is equal to 2, and vice versa. It is equal to what if Pi is equal to Pj? If Pi is just equal to Pj, then the market is getting divided. Each firm is getting half of the demand, which means that Q that we were talking about, Q was equal to alpha minus P. Each firm will get only half of it, which means that this first component, the alpha minus Pi, the first term within the bracket, each firm will get only half of that, which means that this is going to be alpha minus Pi divided by 2 multiplied by Pi minus C if Pi is equal to Pj. And finally, if ith firm's price is greater than the jth firm's price, nobody is going to come to him, and its demand that it caters to is going to be 0, cost of production is going to be 0, and so profit is going to be 0. So, this is the last case. So, here I can be 1 or 2. Now, we are going to find out the Nash equilibrium given this setting. Before we systematically find what is the Nash equilibrium, let us try to look at the response of each firm given the price charged by the other firm. We know that the unit cost of production of each firm is given by small c. Now, if my rival charges a price which is greater than c, then what will be my best response, or what price shall I charge to maximize my profit? Remember, here price, that is Pi or Pj, is a continuous variable. It can take any fractional value, no matter what how close it is to a particular value. It can take any closest possible fractional value. Now, if the price of the other firm is any value greater than c, then if I charge the price that he is charging, then we share the market equally. So, I get some profit, because why I am getting some profit? Because the price in that case is greater than c, and if the price is greater than c, there is positive profit margin, and if there is positive profit margin, the total profit is obviously positive. But what is the price that I charge which maximizes my profit? If I charge the price just equal to his price, I share the market, earn positive profit, but can I do better? And the answer is yes. If I charge a price which is just a little bit less than c, I capture the entire market, because remember, if my price is less, the customers are going to come to me, not go to him, and in that case I cater to the entire market. So, instead of sharing the market with him, it is better of course for me to charge a price which is a little less and get the entire demand in the market. So, that is my best response. However, if I look at this profit function, this pi I is equal to alpha minus p multiplied by pi minus c, this profit function tells me that at a particular price, this profit function must be attaining its maximum. It is going to be a concave profit function. Now, which means that if the other rival, my rival is not there in the market, there is an optimum price at which my profit is getting maximized, and that is the monopoly price. That is the price I should have charged if there was no competition, which means that if my rival is charging a price greater than that monopoly price, my optimal response should not be charge a little less than his price, but charge that monopoly price, and that monopoly price might be quite less, it might be much lower than the price that he is charging. So, in those cases, my strategy is not to undercut him, but forget about his price, but charge the price that maximizes this pi I. So, these are the two cases where his price is more than c. If his price is less than c, then what should I do? If his price is less than c, then remember, if I charge a price less than his price, I get the market, but what is the profit? It is negative, because the profit margin is negative here. The price is less than, his price is less than c. So, it is not optimal for me to charge a price which is less than his price. Then what is the optimal thing to do? I shall not charge a price less than his price, neither shall I charge a price which is just equal to his price, because if I charge a price just equal to his price, again the market is getting divided. If the market is getting divided, then the negative profit that he is earning, I get half of it, which is not a very good thing to do. So in that case, what I should do is to charge a price which is just a little higher than his price. So that is what I should do. And finally, if his price is just equal to C, that there is no profit margin, he is getting zero profit in that case, then it is not optimal for me to charge a price which is less, because if I do, I get negative profit. In that case, either I can charge his price, in which case my profit is 0, but it is equally well if I charge a price higher than his price. In that case also I get 0 profit. So this is the general discussion, but can we from this general discussion find out what is the best response function of each firm, and what is the Nash equilibrium? So let us look at that. To begin with, let us try to draw the profit function. So this is Pi and this is pi. I know the profit function is given by this. Now, if Pi is equal to 0, this profit is a negative quantity, which is minus C alpha, which means it has a negative intercept. Given that it has a negative intercept, at what points does this profit function intersect this horizontal axis, that is Pi? Pi is 0, sorry, pi I is 0 if Pi is either C, in which case the first term is 0, or if Pi is equal to alpha, in which case the second term is 0. I know that alpha is greater than C. So if C is here, somewhere here, and alpha should be somewhere at a higher level. So these are the points through which the curve will go through. It will have a negative intercept. Let us call this to be minus alpha C. And what about the shape of the curve? This curve is going to be a concave curve, concave to the Pi axis. I know that because if I take the second derivative of pi I with respect to Pi, I get a negative term which is minus 2. If the second derivative is a negative quantity, then the curve is a concave curve. So the curve will be most likely having a shape like this. So this is the shape of the profit function, and there is a point just in between which I shall call Pm, at which profit is getting maximized, which means that if there is no other firm, there is no rival to this firm, firm I, then the firm I should charge a price Pm, because at that point the profit is getting maximized. So that is the ideal situation for the firm. But what happens if there is a rival? Now if there is a rival, then the rival charges a price Pj. Now depending on the location of Pj, how Pj compares to Pi, the response of I will be different, and that is what we have seen just now from our discussion. So, and the crucial thing to decide, or the crucial thing to consider, is the relationship between Pj and C. For example, suppose Pj is here, this is Pj suppose. So the rival firm is charging a price less than the unit cost of production. In that case, what is the price that I should charge? Well, if the rival firm is charging a price less than, is equal to Pj, which is less than C, then this part of the curve, this part which is after C, no, after Pj, is getting, it's not relevant anymore, because if I charge a price greater than Pj, my profit is not given by this curve, but by my profit is given by this horizontal axis, because I am getting 0 profit. If I charge a price just equal to Pj, then my market is divided, the market is divided between him and me, and so I get half of the profit that he is earning a negative profit, I get half of that, so I get profit which is half of that. So my profit function is this part, because if I charge a price less than his price, my profit function is coinciding with this curve. If my price is just equal to Pj, I get half of the market given by this point. If my price is higher than Pj, I get profit represented by the horizontal axis. In that case, what should I do? The ideal thing for me to do will be charging a price greater than Pj, strictly greater than Pj, but that price can be any price, it does not matter what price it is. So if so this is what I can infer from this diagram and our argument, that if he is charging a price less than C, I should price my product strictly greater than his price. What if his price is just equal to C? So this is C, this is alpha. Suppose this Pj is here. Now if the price is just equal to C, then if I charge a price less than C, that is Pi is less than C, then I get the market, but then this part of the curve becomes relevant, and if this part is relevant, I can immediately see that my profit is negative, it is below the horizontal axis. So I should not charge a price which is less than Pj if his price, that is Pj, is just equal to C. What should I charge then? If I charge price equal to C or greater than C, then my profit is not given by this curve that I have drawn, but by this horizontal axis. I am getting 0 profit in that case, which means that I should do that. Because I am not earning positive profit in any case, so what I can best do is to earn 0 profit. So Pi Pj is equal to Pi such that Pi is greater than or equal to Pj. If Pj is equal to C. So we have two cases, one is Pj is less than C, one is Pj is just equal to C, and we have seen that the best response functions are different. Thirdly, suppose this price is Pm. Thirdly, if Pj is greater than Pm, suppose the price that he is charging is more than Pm, then what should I do is that my maximum profit is being attained at Pm. So I should charge a price which is Pm, because by charging Pm I am getting the market, at the same time I am maximizing my profit. So in that case my profit is my optimum price is Pm. So, it is just a single value if Pj is greater than Pm. What happens if Pj less than Pm or equal to Pm, but greater than C? What should the firm do, firm I do? This is something which we shall take up in the next class. So, before wrapping up this particular lecture, let me take you through what we have done in this lecture. We have concluded the section on Cournot equilibrium and Cournot model as such, and we have seen that the Cournot model essentially depicts a situation of overgrazing of common resources, in the sense that people tend to overproduce in Cournot equilibrium than what they should have produced if they were interested in maximizing their joint profit. That is, so there is a general model in which we can fit in the Cournot model. And secondly, we have started our discussion of Bertrand equilibrium, which is a different from the Cournot model, in the sense that here the producers are deciding their prices and trying to maximize their profit. We have started the discussion. We shall continue with this in the next lecture. Thank you. Question: how can the Nash equilibrium in the Cournot model be seen as an outcome of overproduction? In Cournot equilibrium, production of output of each firm is equal to alpha minus C divided by 3, and the profit is we have seen alpha minus C divided by alpha minus C whole square divided by 9. Now, we have also seen that if they cooperate, if they collude and maximize profit, maximize joint profit, they should produce alpha minus C divided by 4, which is in fact less than alpha minus C divided by 3, and earn alpha minus C whole square divided by 8 as individual profit. So, it turns out that when they are not colluding and acting as individual players, then they are producing more alpha minus C divided by 3 compared to the case when they collude, because when they collude and maximize the total profit, they produce alpha minus C divided by 4, which is less. And in fact, in collusion their profit is more than when they operate individually. So, that is why we say that in the equilibrium, in the Cournot equilibrium, the firms are ending up by producing more, and when they produce more, the prices go down and profit also is less than what it could be. Okay, the second question: in the Bertrand model, which variables the firms have control over? Briefly describe the model. Firms here decide individual prices. So, if there are two firms, P1 and P2, they do not decide by their own wish what the output that they are going to sell in the market. Once the prices are announced, the consumers decide which price is the lower price, and if they go to a particular firm deciding on the fact that that firm is charging the lower price, then that firm will have to meet the demand in the market. So, the quantity produced by the firm is not decided by the firm, it is decided entirely by the
demand in the market. Okay, this was the part 1 of the question. Briefly describe the model. So, in terms of game theoretic language, there are n firms, suppose, which are the players. Actions, each firm decides the price, which is a non-negative number, and payoff. Payoff is given by payoff of each firm is given by profit of the firm. Okay, so let us say pi I, it is a function of P1 and P2, and it is given by the following: pi Qi minus C Qi. What is Q? Q is the market, nothing but market demand, which is given by alpha minus Pi minus C, again alpha minus Pi, and so this is equal to alpha minus Pi minus C if Pi is less than Pj. Okay, if my price is less than the competitor's price, then I get the entire market. So this demand function, this one is valid for me. If the prices are equal, then we share the market, so it is half of the same price, same profit. And if it is my price is more than the other firm's price, then I get 0 share of the market. I do not sell anything, and my profit is also 0. Okay, thank you.